This section examines AWS step functions and how to use its elements and interface to build pipelines. AWS step functions can help you coordinate components of distributed applications and microservices by using visual workflows. Step functions provides a reliable way to coordinate components and step through the functions of your application. The service offers a graphical interface where you can visualize the components of your application as a series of steps. Step functions automatically initiates and tracks each step, and it also retries when errors occur, so your application runs in order and as expected. Step functions logs the state of each step, so you can diagnose and debug problems quickly. Step functions is integrated with Amazon Athena, so you can use step functions to start and stop a query run and get query results. Using step functions, you can run one-time or scheduled data queries and retrieve results from your S3 data lakes. With step functions, you define a workflow as a series of steps and transitions between each step. A workflow is also called a state machine, and states are elements in a state machine. A state machine is an object that has a set number of operating conditions that depend on the object's previous condition to determine output. This means that individual states can make decisions based on their input, perform actions, and pass output to other states. Tasks do all the work in your state machine. A task performs work by using an activity or a Lambda function, or by passing parameters to the API actions of other services. Each state machine starts with an input. The state transforms the input and passes the output to the next state. In the Step Functions console, you can visualize your state machine and get near real-time information on your state machine tasks. Located in the Step Functions Workflow Studio interface, the States browser is where you select states to drag and drop into your workflow graph. The Actions panel provides a list of AWS APIs, and the Flow panel provides a list of flow states. You can search all states by using the search field at the top of the States browser. After you choose a state from the Actions or Flow panel to add to your workflow, drag and drop the state to the workflow graph in the canvas area. A line shows where it will be placed on your workflow. After you add the new state to your workflow, its code is automatically generated. The image in this slide shows the canvas of the Workflow Studio interface. Within the workflow, you can drag and drop states to move them to different places in the workflow. If your workflow is complex, you might not be able to view all of it in the canvas panel. Use the controls at the top of the canvas to zoom in or out. To view different parts of a workflow graph, you can drag the workflow graph in the canvas. After you have added a state to your workflow, you'll want to configure it. Choose the state that you want to configure, and its configuration options appear in the Inspector panel. To see the workflow code, choose the Definition panel. The code that's associated with the selected state is highlighted. Let's look at the different state types that are available and the functions that they perform within the Step Function service. Each state has a different function. A task state is a single unit of work performed by a state machine. All work in a state machine is done by tasks, using an activity or Lambda function. A pass state passes input to output. As an option, you can add fixed data into the output. A choice state adds branching logic to your workflow. In the Configuration tab of the Inspector panel, you can configure rules to determine which state the workflow will transition to. A parallel state adds parallel branches to your workflow. A wait state will pause the workflow for a certain amount of time or until a specified time or date. A map state will dynamically iterate steps for each element of an input array. Unlike a parallel flow state, a map state will process the same steps from multiple entries of an array in the state input. A succeed state will stop your workflow with a success, and a fail state will stop your workflow with a failure. Let's take a closer look at each of these states and how they are used in Step Functions pipelines. A pass state passes its input to its output without performing work. Pass states are useful when constructing and debugging state machines. The slide shows an example of a state machine that consists of a single pass state. When the state machine runs, it injects some fixed data, which might be useful for testing purposes. A choice state adds branching logic to a state machine. A choice state must have a choices field whose value is a non-empty array. Each element in the array is an object called a choice rule. A choice rule contains the comparison field and the next field. The comparison field consists of two fields that specify an input variable to be compared, the type of comparison, and the value to compare the variable to. The next field contains a value that must match a state name in the state machine. In the example on the slide, the first choice rule checks whether the numerical value is equal to 1. The second choice rule checks whether the numerical value is equal to 2. The parallel state creates parallel branches in your state machine. A parallel state causes step functions to run each branch, starting with the state that is named in the branch's Start At field, as concurrently as possible. The workflow will wait until all branches reach a terminal state before it processes the parallel state's next field. A wait state delays the state machine from continuing for a specified time. You can choose either a relative time, which is specified in seconds from when the state begins, or an absolute time, which is specified as a timestamp. You can use a wait state as a form of timer for your workflow. In the example on the slide, the wait state introduces a 10-second delay into the state machine. You can use the map state to run a set of steps for each element of an input array. While the parallel state processes multiple branches of steps by using the same input, a map state will process the same steps for multiple entries of an array in the state input. A succeed state stops running a state successfully. The succeed state is a useful target for choice state branches that do nothing except stop running the state. Because succeed states are terminal states, they don't have a next field, and they don't need an end field. A fail state stops running the state machine and marks it as a failure. The fail state requires the type field, which specifies the state's type. In addition, the fail state allows the optional cause and error fields. The cause field provides a custom failure string that can be useful for operational or diagnostic purposes. The error field provides an error name that can be used for error handling, operational or diagnostic purposes. Because fail states always exit the state machine, they don't have a next field, and they don't require an end field. The slide provides an example. Step Functions is integrated with Athena to facilitate building workflows that include Athena queries and data processing operations. This integration helps you create repeatable and scalable data processing pipelines as part of a larger business application. You can visualize the workflows on the Athena console. In the example on the slide, the raw data is in a tab-separated values or TSV format, and the data is ingested daily. As information is ingested, the AWS Glue crawler is used to provide updates to the raw data catalog. You use the Athena unload statement to convert that data into Parquet format. After conversion, you send the location of the Parquet file as an Amazon Simple Notification Service or SNS notification. You can use Amazon SNS to notify downstream applications to take further action. One common example is to initiate a Lambda function that uploads the Athena transformation result into Amazon Redshift. Here are a few key points to summarize this section. With step functions, you can use visual workflows to coordinate the components of distributed applications and microservices. You define a workflow, also referred to as a state machine, as a series of steps and transitions between each step. Step Functions is integrated with Athena to facilitate building workflows that include Athena queries and data processing operations.